I gave my AI coding agent a feature to build overnight, and it came back with 6 code changes packaged in what's known as pull requests if you're new to programming. And these pull requests, also known as merge requests, are, in this case, stacked on top of each other. Sometimes that's a more efficient way to build out features, is you can, if they're independent features that can be built independently, they can be fully independent pull requests. But if they're features that depend on each other, then they can be stacked on each other. So let's jump onto my computer screen, have a quick look at the stacking process for these branches so you understand what happened. So now we have a look here. This is my coding agent. Basically, it's saying it's created all of these pull requests and it's stacked them on top of each other and has given us a merge order here. But sometimes what it says here, it's not clear what the merge order is. And once we have a look at the branch naming convention it used, we'll understand the merge order. So before I continue on looking at my GitHub branches, like, why is this important? So when you build a feature, sometimes the feature is huge, right? And it might touch 4 different areas of the code base. You know, it might touch the API, the database, the migrations, the front end as well. And it could get unorderly. If you've got one pull request with 400 lines of code, then that's not as good as, 4 pull requests with 100 lines of code. The reason why that is that usually when you're a developer, say you're a senior developer in an organization, you have a pretty good understanding of the institutional level of the code bases that these code changes will touch. But an AI doing it, often they don't have that level of understanding and where it fits in on the grand scheme of things. And with AI, we're relying on AI more and more to build our systems, but we don't want it to just submit code in a black box that we deploy to production. That's a huge red flag. So this is why we want to break things down into smaller bite-sized components and submit them as pull requests. There is kind of some theories around how pull requests are dead, but in a production environment with, hundreds, if not thousands of users or millions of users, there's no way that there would be an engineering team that would allow an agent full access to deploying to production, even if it does follow small bite-sized commits directly into the main branch. It's just not going to happen unless there's a new workflow that gets created in the future. But at the moment, using the confines of the current flows and architecture, you submit smaller atomic commits, and we don't want it to be a black box. So I want them to be small and reviewable. An atomic commit is a small piece of functional code, which is basically the minimal amount of code needed for it to be functional into that pull request. And that's important for traceability because the Git history needs to tell the story now that the humans aren't sort of in the code as much. The history needs to tell the story. So if something breaks in production, you're rolling back just one small sort of commit and pull request as opposed to a 400 line commit, which and just sort of hope that works. So let's jump in now to my, so this example is, I've got all of the pull requests lined up from that chat, and you'll see that there's some common flow here. They don't always flow like this. Sometimes you might get some work that's done with independent pull requests and then 1 or 2 stacked pull requests as well. And they can stack, the depth that they can stack is infinite. Now, the brand, for example, this one, it is merging this brand local prompt audit into brand locale delivery. So if we go to the next one, so then now the brand locale delivery is merging into brand locale QA, and then the brand local QA is merging into brand local onboarding, and the brand local onboarding is merging into brand local generation. The brand local generation is merging into the brand local settings. And then finally, the brand local settings is merging into main. So you start at the top of the, well, they say bottom. It's actually called the bottom of the tree. So it's always bottom up. Bottom meaning that the furthest child away, and you collapse that into the common denominator. But sometimes you could have a tree. You could have a parent branch with multiple children. So it could extend out, fan out horizontally. But then any of those children could also have a vertical tree as well. So you just need to think like trees. And programming like this in an agentic way does require you to have that mental model of these trees to understand before you merge it all in. Because what happens if you say, for example, if you merge a parent branch into main before merging the children branch, nothing horrible will happen, but unless there's a broken code change in there. But what happens is any of the children become orphaned, and that code is just ghost code on a branch that's likely merged. Depending on your GitHub setup, it could be closed as well. So you need to track, if you're controlling this, you need to track that mental model if you're doing stacked PRs. But the biggest advantage of doing stacked PRs is that you can merge everything into one PR once and test it along the chain, and then once it's finally ready, you can merge it into main. It's not always the best way to do things, and some engineering shops might not like stacked PRs. But another advantage of it is that AI agents can actually oftentimes work on stacked PRs in parallel, which seems a bit counterintuitive because one PR relies on the next. But actually what can happen is if the planning side of things is done to a point where it actually understands the contract between, say, the API layer that you're adding, and it can infer, if they know what the shape of the contract would look like or the database schema looks like, it can infer and basically branch off and create another pull request early on in the stage. So it's not always sequential, but you do have to merge them sequentially, which is an important aspect of this. So that's pretty much all I wanted to talk about. So when I merge this, I've already reviewed these PRs. If I merge these, I start with the maximum depth one, which is the bottom of the chain. And because I know all 6 of these are in a sequential order, it's a process where I have to merge one by one. But then there's a good little check you can do to make sure it's all merged. So I've already put these in order that I need to merge them. So if you had the tabs out of order, that's when it can get a little bit confusing. So these tabs are all in order. So I already know that, now I'm merging brand locale into brand locale generation, and then brand locale generation into brand locale settings. And then we have the brand locale settings finally go into main. Now, what you might do at the parent one is, if you've got a staging environment set up, is actually go and just test this one. Obviously you'd probably test all of them, but if you had the time, but testing this one is like the most critical one because it's about to merge into main. So I've already tested this flow. So I'm confident that is fine, but I'm not going to merge it just now. But what I was going to say is, if you switch back to your coding agent, you could say something like, okay, I've merged all of them into the parent, and give the number 1723, local contract and settings. And you could, can you confirm that all of the stacked PRs have collapsed or been merged into 1727? So yeah, that's it. If you're wanting to grab a agents.md file, which explains this parallel concurrency and this traceability concept to your agents in whatever project you have, and you just paste it in, let me know in the comments and I can try and send it to you, or I'll give you access to it. I might put a link to it in the comments below. Cool. Thank you.